Hello everyone, my name is José Morgado, and today I'm going to be showcasing the current status of the CARM Paraver integration. First, I will just give a small introduction to the Cache-Aware Roofline Model. So the CARM is an easy-to-understand performance model, which can give you an accurate performance overview of your application for a particular system, and provide you with good optimization hints to help you prioritize your efforts in the right direction to achieve better performance quicker. But how does the CARM model actually work? So basically we have two main roofs, the sloped roofs, which are dictated by the maximum bandwidth of each memory level, and the flat roof, which is determined by the maximum floating point performance of the system. These roofs define two areas below them. These are the memory bound area, in red, below the sloped roofs, and the compute bound area in blue, below the flat roof. If your application is plotted in the memory bound area, like the first point in this graph, then you should first try to improve memory access related parts of your code. So things like improving access patterns, data transfers, or cache usage, for example. Then, if your application is plotted in the compute bound area, like the last point in this graph, you should first try to improve the utilization of the arithmetic units of the CPU. So strategies like using vector instructions, parallelization, among other things. And finally, we also have the mixed area, which is situated between the other two. And in this case, our application can likely benefit from both memory and compute optimizations. So now I'll also give you a brief overview of what the CARM Paraver integration consists of. So this integration allows for CARM-based application profiling of extra traces alongside Paraver timelines, with CARM results being provided by the CARM tool, which is available in the Champ GitHub page via that QR code, where you can also find the standalone CARM tool and the CARM Paraver GUI. So the CARM GUI is integrated with Paraver as a separate module, and the current features of the integration include the synchronization of Paraver timelines with the CARM GUI, exporting of Paraver timestamp coloring and mask to the CARM GUI, and the exporting of CARM-related metrics to Paraver. Now moving to the demo part of this video, I'll be showing you how you can get and use the CARM Paraver GUI. So first off, you can clone it from GitHub like I've done here. And then if you have any missing requirements in terms of Python modules, you can install them using the requirements.txt file. Then the only other thing you need to do is to set the path to the CARM Paraver directory in your path, and also to the parameter installation, which is usually located inside the bin folder of Paraver. So you can either do this manually with the export path command, or you can set it up permanently on your computer by using our setup script. All you have to provide is the path to your parameter installation, like so. And then you can start up Paraver. So here, for this example, I have a trace that I've collected. And I also have a configuration demo to help you visualize the CARM metrics. So here in these timelines, we can see some different CARM metrics like arithmetic intensity and flops. And here I've also created a mask showing us just when AVX512 operations are executed, marked in blue here. And as you can see, this code basically consists of some different phases, which go through AVX512 operations, AVX2, and also SSE. And so what I'm going to do here is launch the CARM GUI from the window on the bottom. And here we get this panel to control the CARM GUI launch. So here you have some options that you can set from the start, like the minimum timestamp duration, to use window colors from Paraver, or to use the mask or semantic window from Paraver, and also to accumulate values from this mask. So all of these options can also be toggled on and off later inside the CARM GUI. So these are not permanent options, and you can change them. So now I'll just leave them off and run the CARM GUI. So after the CARM GUI finishes calculating metrics, you get this link which you can open in your browser, which I already have here. So first you'll get a warning about any missing counter data, and in this case my trace only has low precision counters, so I could also monitor single precision counters if I wanted, and these are the values that they have in Extrae. So now I can select results from a machine. And in this case, I'm using Mare Nostrum 5, which are the default results included in the CARM GUI GitHub. So first off, we can plot the entire timeline that we see from Paraver here. So this matches up with what we have here. And in this case, we are using the CARM coloring. So the CARM coloring has some different options. And for example, the vectorize option, which allows us to distinguish between different vectorizers being used in the different timestamps. And we can see here the different AVX512 timestamps and also AVX2 and SSC. But we can also use the Paraver colors with this option here. So now in blue, we get the timestamps that are also marked as blue in Paraver, and then in black, we get all the other timestamps that don't have a matching color in Paraver. As you can see here, we only have blue and nothing else. That's what we get on the CARM GUI side. And then if we use the semantic window from Paraver, we can actually filter out all of the points that are also not displayed in Paraver. So if I do this and then plot all of the points, we can see that we only get the blue ones from the AVX512. And you can also now plot accumulated values, and that will do an average of all of these points over the period of the mask. So now we just get 2 points with the average of the computations performed in these different sections you see here. So now you can also sync up your timeline with Paraver. So in this case, what you can do, for example, if you zoom in a particular section using Paraver, you can then use the time sync feature here to synchronize the CARM GUI with that. So you can see here that we have now selected automatically the same range that is being visualized in Paraver. And if later, for some reason, you move away from this range in the CARM GUI, you can still come back to it by clicking the resync timeline, and this will show you exactly the part where you were before. You can also send to Paraver some CARM-related metrics, and these include the roofs under which the timestamps are. So to do that, you can click on this button here, and now you will get an output CSV, which you can open in Paraver like this. And then by creating a new timeline window, you can visualize the CSV, and you can check under which CARM roof do each of the timestamps fall under. You can also export some other CARM-related metrics by using these two different options. So you can send load star percentage ratios and single precision, double precision ratios in the same way that I just showed you for the roofs. Finally, you also have some different options you can choose here on the CARM GUI to filter the different timestamps you see based on the gigaflops values, the duration, and other metrics as you'd like. So after watching this demo, you should now be able to plot and analyze your own Paraver traces and timelines with the CARM GUI analysis component. If you have any doubts, feel free to comment on this video with your question, and thank you for watching.